Hey again, Honors Chemistry. This is going to be a very important video that I'm going to walk you through stoichiometry and using PV equals nRT. So we're going to be using this equation, and remember, PV equals nRT is pressure times volume, pressure is in atmospheres, volume is in liters, is equal to N, which is moles, times R, which is this gas constant, times T, which is temperature in Kelvin. So it says when 4.52 grams of zinc is allowed to react with excess hydrochloric acid, which is HCl, zinc chloride and hydrogen gas is formed. If the reaction is held at 298 Kelvin and 1.2 atmospheres, what volume of hydrogen gas should form? So whenever I give you a chemical reaction, I want to write the balanced chemical equation. So it says zinc is allowed to react with excess hydrochloric acid. So zinc and hydrochloric acid to produce zinc chloride. Now, a lot of us kept on making mistakes on writing the formula for zinc chloride, but you need to know that zinc is 2 plus, chloride is Cl minus 1. So if I crisscross or crisscross method, I will get ZnCl2. That is zinc chloride. And then hydrogen gas, hydrogen is Hofbrinkel. So plus H2. And just upon inspection, there's one zinc. There's two Cl's, one Cl, two H's, one H. The only way that I can get there to be two Cl's and two H's on both sides is if I put a big 2 there. Okay? Then I could do a BCA table or whatever stoichiometry you use, but remember, I always show my answer keys with BCA tables. Okay? And it says I have 4.52 grams of zinc. 4.52 grams of zinc. Remember, if I want to do any type of stoichiometry or reaction to relate zinc to hydrogen, because that's what the question is asking about. If I have 4.52 grams of zinc, how much hydrogen can I make? Eventually it says volume. Well, if I have 4.52 grams of zinc, the molar mass of zinc is 65.38 grams per mole, which means I have 0.069 moles of zinc. So that goes in my before in the BCA table. And it says I reacted with excess zinc, HCl, and I actually don't even care about HCl or ZnCl2. The question's not asking about that. The question's asking about Zn and H2. So if I'm reacting all of my Zn, I start with 0 H2. This is a 1-to-1 mole ratio. So if I use 0.069 moles of zinc, I should be making 0.69 moles of H2. That's how much I'm making. Now, if you were unconvinced about how I did that calculation, I literally did 0.69 moles of zinc times 1 mole of H2 over 1 mole of Zn, and I get 0.069 moles. All right, that's very messy, but I did dimensional analysis also in a way. All right, so now I know how many moles of H2. That's my value of N. My N for H2 is 0.069 moles. But the question asks for volume. How can I get volume using the ideal gas law equation? Well, I could rearrange this. Volume is equal to nRT over P. So if I have my number of moles now, and I'm going to zoom on down. If I have my number of moles now, I could plug and chug into PV equals nRT. And I'm going to use the rearranged version of it. So V is equal to nRT over P. I know that my N is 0.069 moles. Let's look back at the question. Did they give me a T? Yeah, they did. It's 298 Kelvin. So I got my temperature, 298 Kelvin. Did they give me a pressure in the problem? Yep, 1.2 atmospheres. So I'm going to write that down. So 1.2 atmospheres. And then R, of course, is the gas constant right here. So 0.08206 liters times atmospheres per mole Kelvin. Now, all I have to do is plug and chug. If I want the volume of H2, I'm plugging and chugging into this equation. N is 0.069 moles of H2. R is 0.08206 liters times atmospheres per mole Kelvin. And these I always include the units, and I'm going to show you how they cancel out. T is 298 Kelvin, and P, or over P, is 1.2 atmospheres. And now I'm going to show you how my units cancel out. Atmospheres will cancel out with atmospheres, Kelvin with Kelvin, moles with moles, and I'm really only going to be left with liters. If I do this math correctly, my volume of hydrogen gas should be 1.41 liters of H2 gas. That should be my answer. All right, and so this is an amazing work through question, and this could definitely and easily be, and it is, a final question. A big hint is if it's asking for a volume and it gives you a temperature and a pressure, I'm definitely going to be using ideal gas law equation and having to solve for moles with my BCA table and then plug it into V equals nRT over P. Alrighty, so hopefully this video was super helpful. We're going to move on to worksheet number 2. I'm going to do 1 or 2 more examples, and then you should be all set for completing worksheets 1 and 2.